Hello everyone, good afternoon. To- Thanks for coming for this talk. Today we are going to talk about beyond security, leveraging OPA for FinOps in Kubernetes. My name is Sathish Kumar Venkatesan. I'm coming from Canada. So I run a website, DevOpsCloudJunction. So it's a community website. We talk about cloud native AI, other technologies. I'm passionate about computers, electronics, photography. I love to contribute to open source projects. I've contributed to multiple projects. I like to attend community events like KubeCon. So today we will cover about the FinOps challenges, whatever we have in the Kubernetes environments, OPA fundamentals and capabilities if we are not aware of OPA, and then like how we can extend OPA to cost governance, which is like FinOps practices, and then like I'll show some example FinOps policies, which is written in Rego, and how we can adopt and then how we can implement in your environment. Towards the end, maybe I will show a demo with set of policies which I've applied in my environment. So just a quick overview of like what is FinOps. So FinOps is a practice in a dynamic cloud environment. It's very hard for everyone to keep track of like what's happening in your cloud environment. So come up with this key goals, inform, so make sure that the your cloud bills have visibility. You can view those cloud spend effectively, and then optimize. Try to choose like what's the correct right size instance which you want to use, and then go for like reservations instead of trying to use on demand to reduce cost, and then operate. Basically, like try to have a continuous process to identify and then remediate those overspend. The FinOps challenges, whatever we have in the Kubernetes environment right now, like in the Flexera state report, it says like 32% of the resources underutilized. And then there are like other common issues, basically like over-provisioned resources, there are like idle workloads, and then non-optimal node selection. So whenever people try to provision those clusters, we don't know like what's the right SKU to choose. So we just provision some SKU, and then like later we see like, okay, it's not effectively being used. And then resource quota, so like we don't specify, we don't restrict those workloads to have required resources to be used. Instead of like we allow people to leverage whatever the underlying hardware it's capable of the resources. And the untag resources, so it's a problem like in the chargeback, like if you are not able to charge to the right team, and then you like not able to like keep track of like what's happening in your cloud environment. So this is a latest Caste report which says like in a group of Kubernetes clusters, whatever they are surveyed, so it says like only 10% of the CPU being utilized, and then like only 23% of the memory being utilized, like remaining like over like 50% of the memory is like wasted. Like we are just paying for it, but we are not really using it. So I would say like we need some guardrails here to protect the cloud span. So that's why we can make use of OPA. So OPA is a CNCF graduate project in 2021. It's like already 4 years. It's a policy engine, so you can control you can write policies for Kubernetes, Terraform, Envoy, and much more. You can use the same policies to control multiple environments, and then like it can be version controlled. And then basically the thing is like you don't have to add the logic in your application and stuff, that this policies takes care of the decision maker, which decides like what you can do once it evaluates the policy. So this is a sample policy, for example, OPA policy. So here we just say, okay, this is particular user, and then this is the HTTP method, and then this is the endpoint where a person is trying to access a user's endpoint, and especially like the user allies here, that's the one who will be able to access this particular endpoint. It provides you an output saying like deny, then you can, based on that condition, you can decide like what you want to do, whether you want to allow this particular user to access the admin page or like user's page in this case. So as I said, OPA is written in Rego language. The policies are version controlled. It decouples the application logic, so you can keep the policy decision in the decoupled manner. And then it's centralized. You can have all the policies which you have in your centralized in your current environment in a single pane. So why FinOps why OPA for FinOps? So obviously I would say like, how many of you here are using OPA in your environment? Nice. So I think like most of you are using OPA to like security controls and then like check for compliance and stuff. So we can reuse that existing tool in your landscape for like this kind of FinOps purpose as well. So as I mentioned before, so it's a single policy framework you can use for multiple domains. Shift left approach instead of like you allow the developers to provision the resources and then like go back and then check for the cloud span. Instead of that, we try to restrict whenever they're trying to provision the resources. So that way it's easier to deny those overspend. Next thing is like GitOps friendly. It's version controlled. You can have it in a Git repo and then have a GitOps Flux CD, Argo CD, CD tools to go and deploy those policies in your target Kubernetes clusters. So this is OPA Gatekeeper. So it's a Kubernetes integration. So this OPA Gatekeeper is written uses OPA language. So basically, it's the same thing. It's Gatekeeper is an admission controller, so it checks for the policies. It sees, it validates the policy and then makes sure like if it needs to be allowed or denied. It provides you auditing capabilities for existing resources as well. If you're trying to deny your incoming request, but it can still go and validate your existing resources and see if there are violations for those existing resources. So this is a traditional approach. Most of the people here might be using it. For example, image policy enforcement. Here in this case, like you want to restrict this particular image registry to be used. You don't want people to use Docker IO or GCRI or public registry and stuff. That you want people to use private registries and stuff. Network policies, for example, like you don't want people to do cross communication within your clusters, or like don't want people to let traffic go outside of your cluster to an external domain, google.com or something like that. And then secret management, for example, like some people may be denying that using environmental variables and stuff, that using a secret ref or like Kubernetes secret in the secret ref or like external secret management tools. And then compliance validation. So for example, like you can, there will be certain policies basically like to restrict privileged container to be running on this cluster. So that's what to check if it's compliant, and then if it's violating your security features, security violations. And then for FinOps, basically here I'm trying to say like, okay, we can just add tagging and stuff to meet the compliance, and then like compute optimization. So like whenever a user is trying to provision the resources, you can just check like if those resources are compliant, and then like if you are allowing those particular resources to be utilized. And then namespace allocation on the namespace level, you can add some budgets and make sure like, okay, this is my budget for the whole namespace, and then these many workloads are trying to use this only the particular spend like within that namespace. And then for example, like there could be a storage cost optimization policies as well. You can have like premium SSDs, standard SSDs, standard disk, and then premium SSDs. You can decide like which storage your application team has to use, so you can deny based on that. So this is an example of a certain policy. So here I'm trying to say, okay, if a particular deployment is trying to use more than one CPU or 1000 millicore, try to deny that request, right? So whenever they are trying to use furthermore, then like you can either flag it, then you can decide the enforcement action. You can deny, dry run, and warn. So warn is like audit, and dry run it just doesn't show any information to the users. Deny is straight away deny. It doesn't allow you to objects to be created. So this is another example where you can dictate saying like, okay, we want non-production workloads or dev workloads here. In this case, make use of Spot instance, which is like 70-80% cheaper than the on-demand or reserved instances. So you can dictate saying like this particular workloads going to this particular namespaces need to have these labels. So they can just make those changes and then get those things deployed. And then this is for the cost allocation. So we can know like having these labels, make sure that whenever you want to do a chargeback in a multi-tenant cluster, it's easy for you to charge back to the respective application team or business units. So this is on the namespace level. If you want to globally control the spend on the each namespace, you can have a policy on the namespace level to restrict the overall spend on this particular overall resource creation on this particular namespace. This is the other one I was saying about storage optimization, where you can dictate, okay, premium SSDs and supreme ultra disks need to be used only on the production, and then critical, whichever has the critical labels, and then like denying all other all other namespaces. So we can further do some more, like if you have external tools, like which is already calculating the cost, you can make some API calls to that and then get some metrics, and then based on that you can still go and deny those traffic, go and deny those requests basically. So how do I get started? So I would say like try to start small, check what is the current utilization in your environment, see what's the request being utilized, and then like what is the CPU request being requested, and then like what is being used, and based on that you can decide a policy, and then you can dictate like, okay, if I have a GPU workloads, only GPU related workloads should use the GPU nodes, not the other workloads. So instance based constraints you can create, and then budget enforcement. So you can create a namespace based or namespace based policies so that you can clearly know like what's your spend on the namespace, and then like to keep track of the namespace. And then finally, like furthermore, you can do like auto remediation. So like once you see all those violations, you can have make those change, like you can create a like even OPA can do not only validation, it can do mutation. So you can make those changes, like say like if your CPU utilization is less, and then you can go ahead and then make those changes, modify those CPU requests and limits. So here it's a team effort basically, like you need a collaboration with your platform team, security team, and finance and application teams. They all to work together. Whenever you create any policies, sometimes there could be an exception, like where you want to allow certain policies to be allowed for some exception cases. So maybe you can come up with some extra annotations by which you can temporarily bypass that particular request, and then document all those policies, and then explain the end users like what this policy does, and then like how it's effectively being implemented in this current environment. And then measuring success is the key. Try to see like how these policies help in your organization to whether it is like helping you to like reduce the cost which you're overspending, and then monitoring the violations, and then see like if you're trying to come down, if you're like if the violations are coming down, if you're in track. So these are the common challenges we will usually face whenever we trying to implement. So it's policy, as I mentioned, it's a users rego. So you need to like have some good test cases written. Maybe you can use OPA test or conf test to evaluate those policies, and then try to do it in a dry run mode, so that like end users are infected, but you can come to know like what's the violations in your current environment. And then, as I mentioned, like there could be some exception cases. You create an annotation so to override the violations or to allow the particular request. Next is cloud build is keep changing, so you need to keep track of like what's happening. So you need to have a real-time integration, or like try to correlate with whatever is happening in your cloud span. Next, I would recommend like to have those policies in a GitOps way, so that like whenever you make those changes, once it's merged, it gets implemented, so it's not like outdated, sitting there in a repo, and then it's not applied on your cluster. So these are the resources I would recommend. So going to the OPA GitHub repo, or OPA Gatekeeper library. So the Gatekeeper library has a set of default set of constraint and constraint templates which you can play with, and then you can enhance those policies in case like if you want to further make changes. And then obviously documentation is the key. So you can go through the OPA documentation and then the Gatekeeper documentation. And then obviously join the Slack channels, and then like you can ask the questions if you have any doubts or like if you are facing any challenges. There are a lot more community members for you to help. Yeah, towards a demo, I'll just show some of the I'll try to show you like certain scenarios, how it can be used. So in this specific cluster, I just have OPA Gatekeeper installed, and I'm sorry about that. I have a Gatekeeper running here, and then just have OpenCost running as well. So what I'm trying to do is, let me show you. So there are like multiple constraint templates I applied here. So these are the custom CRDs which are created using those constraint templates. I'll try to show some example here. One of those policies maybe. So right now I'm trying to create a PVC, for example. So I am trying to, is it clear? Yeah. So if you can see here, I'm trying to create a premium SSD, like try to use the storage class premium SSD in the dev namespace. So when I'm trying to apply this specific manifest, so immediately the policy, immediately those resources, it's denied, it's not applied on the cluster. So Gatekeeper is the admission controller here, so it checks for those policies, and then since it's not meeting the condition, like this particular storage class need to be used only on production, prod namespace in this example, but not on dev, so it's not allowing you to create. But let's check other thing. So here I'm trying to do, so here I have a PVC which is on prod namespace. We'll try to apply this one. So it gets created. So the policy is working, so it makes sure that this specific storage class, this specific PVC can be used, storage class can be used for on the prod namespace. Another example I would like to show is here. I'm trying to like create a deployment, and then like I have not specified any CPU resources or memory resources or anything here. So whenever I try to apply here, so there is another policy created, so which is basically checking for those resource fields, and then it says like missing CPU request which is required. So I will show an example now. So yeah, this is an interesting one. So here we are trying to allocate like 3 core CPU. So what I've done is I will try to integrate with OpenCost. So what it does is, I'll show you here. So here I have like 2 policies. First policy is basically like just checking for the CPU resources. It says like at the limit, the min should be the 100 millicore, and then like request should be 100 millicore, and limit should be 1000 millicore. And the second policy is what I'm trying to predict. So based on the OpenCost, it says like, okay, I am trying to like overspend. My limit for this particular namespace is only $5,000. And then if I allow this particular deployment, then it will reach like $7,000. So way I'm trying to do it is I'm trying to get that current spend. And since I'm not running for a long hour, so I'm just trying to check the current minutes used, and then based on that, I'm calculating the CPU spend. So by which like if I allow this new deployment, which is run in 3 cores, which is like over like $2,700. So I'll show you the OpenCost here. So this is the default namespace. So I'm trying to extract this information here. So I created a custom app which pulls that OpenCost API and then like specifically says, okay, this is the amount of 8-10 minutes is where the application is running, and then this much core is being used, and then this is the corresponding CPU cost for that particular workload, those workloads. So yeah, so by which there are like multiple ways you can do it. Like if you have like external other tools, you can integrate that with that, and then like you can block those requests. Yeah, so if I try to apply the other deployment, which is having like a low CPU, it should get created. So here I'm just trying to use just under millicore, which is fitting within the budget. So it is having it, it, it it fits with the budget. The current utilization is just $4,500. For that under millicore, it is still within the limit, so it allowed that particular request to be created. So I'll just show you the violations here, and I will show the constraints. So basically, you can see the violations here, and so I'm trying to run in a different mode. So I'm trying to run in the dry run here. So here you can see clearly, like, so these specific namespaces doesn't have those specific labels for tracking, right? So even if you try to create the namespaces, it doesn't allow you to like create the namespaces, because like it needs so for example, if it is non-compliant namespace which doesn't have those labels, so it would try to say, okay, you need the cost center and environment and other labels. So and then like if you want to track, so maybe like you can create a graph on a dashboard and then see like what are the constraints you have, and then like what are the violations you have in your environment. And so just want to show something here. Certain, okay. Yeah, maybe I'll just show it here. For example, let's show something here. CPU request, right? So you can describe. So you can see here, this specific namespace is missing requests, which is request. So sorry. Okay, get constraint. For example, monthly spend, right? So you can just see, even if it can check for your old resources. So sorry. So the existing workloads, whatever I'm running, it's already like violating that thing. So it shows like it will be like it might exceed. So you can restrict. You can see the violations for that existing workloads as well. It's not mandatory. Like it will check only for the new resources, even for the old resources, whatever got created. It will keep checking those policies against those workloads. Yeah. Any other questions here? Thank you so much. Thank you.
Hi.
Yeah.
I have a quick question. Thanks for the session. The cost, what is the source of truth? Like, where does it get the so is it running on EC2 instance, or what all cost does it consider?
So here I'm trying to use OpenCost, which checks that Kubernetes namespace resources. And based on that, right now I'm just using custom billing, so you can integrate with your cloud provider. So it can keep track, like it can check against your cloud provider cost.
Right. Okay. Thank you.
Thank you.